Dairy waste to power. Part 3, cow waste to biosolids. It's time to look closely at cow waste without looking too closely at it. A typical milk cow will eliminate over 100 pounds of waste in a day. The solid portion of that waste is called feces or manure. It contains cow feed that has not been fully digested. There are still nutrients and energy-providing molecules present and available to be broken down further. The liquid portion of that waste is called urine. Urine is mostly water. Dissolved into that water is a variety of organic compounds, salts, and nitrogen-containing bodily toxins. Each of these toxins is filtered from the cow through its kidneys. Any waste product, in this case a biological waste that contains bacteria, must be carefully managed to prevent harm to our environment. Wisconsin dairy farmers manage their cow waste by treating it as a valuable resource. Dairy farmers collect their cow waste and place it back onto their fields as a fertilizer. This returns nutrients to the land where they started. In this way, these valuable nutrients are not discarded or lost. They are recycled and used to fertilize crops that need these nutrients to grow. On some dairy farms in Wisconsin, cow waste is broken down much further before it is reused to fertilize croplands. It is basically digested a second time, cows having digested their food the first time and turned it into cow waste. This second digestion is performed in an anaerobic digester. After anaerobic digestion, cow waste can be viewed as a remarkably sustainable resource from which these especially beneficial and valuable assets are produced. Methane. Collected and kept out of the air, it is used as a fuel on a scale that can serve hundreds of homes. Fertilizer, broken down much further than raw cow waste, it now holds nutrients in a form that can be more safely managed and applied to croplands. And solids, that can be sold as a soil additive or used as cow bedding. Along with water that is used for cleaning, cow wastes are collected in the cow barn. They are then scraped and pushed into a trough which takes these wastes to the place that will turn them into the valuable assets just mentioned. Scraped and pushed into a trough which takes these wastes to the place that will turn them into the valuable assets just mentioned. That place is the star of this show, the anaerobic digester. The anaerobic digester is the centerpiece of this educational lesson. As you know, there are still substances present in raw cow waste that can be profitably used. They just haven't been completely digested in the day or two a cow takes to digest what she eats. To separate and remove these still useful substances, cow waste can be digested again in an anaerobic digester. Anaerobic digestion can be defined as the breakdown of organic material by microorganisms in the absence of oxygen. In this case, cows are providing the organic material and the microorganisms in their waste. The digester provides the right environment, no oxygen, and the right temperature for further digestion to occur. You may think of an anaerobic digester as a really big stomach. However, it takes a few weeks for the cow waste to pass through this stomach for it to be completely digested. There are several types of digesters for a farmer to choose from. Whichever type is chosen, it will be matched to the size of its dairy farm. The size of the digester will govern its cost. The cost of a relatively small anaerobic digester will start somewhere near $1 million. Capital improvements of this size require a dairy farmer and the farmer's bank to weigh the cost against the benefits of the anaerobic digester carefully. Depending on the type of digester, the cow waste will be broken down over a period of about 3 weeks. While it passes through the digester, cow waste is kept at a temperature of around 100 degrees Fahrenheit. Where does heat for maintaining the temperature of the anaerobic digester come from? Heat from the process of generating electricity is used. This is heat that would otherwise simply be wasted. As cow waste passes through the digester, anaerobic bacteria produce biogas, which is mostly methane, CH4, a high-energy molecule. Break down the organic nutrients, organic nitrogen, phosphorus, and potassium found in the cow waste, putting them into an inorganic form. This is called mineralization. Break down the harmful bacteria found in the cow waste, Listeria, E. coli, Salmonella, etc., in many cases reducing their numbers below detectable levels, and enable most of the odor-causing compounds to be removed from the cow waste. Although large volumes of biogas are created during anaerobic digestion, only a small portion of the original cow waste is converted to this gas. There is still plenty of solid and liquid material that remains. Each of the end products of anaerobic digestion, solids, liquids, and biogas, are now close to becoming highly desirable renewable or recyclable assets. We'll follow the solids and the liquids first to the solids separator. The solid and liquid material left at the end of the digestion process is called effluent. After about 3 weeks in the digester, the effluent that comes out is pumped to a solids separator. The solids separator physically separates the solid portion of the effluent from the liquid portion. The most common type of solid separator is called a screw press separator. With a screw press separator, the effluent is first pushed through a screen, not visible here, which removes some of the liquid right away. The remaining effluent is immediately pushed through a mechanical screw press, visible here, which squeezes out even more water. After the screw press, the process is pretty simple. Solids produced from the digester are conveyed away and dropped onto a pile. Liquids produced from the digester are pumped to a lagoon for storage. These solids and liquid products are no longer waste products, but renewable assets to be managed and sensibly used. Leaving the solids behind for a moment, the liquids are pumped to lagoon storage. First, what is a lagoon doing on a dairy farm? Most dairy farms must have a lagoon to provide temporary storage for their cow waste. But the cow waste stored in a lagoon on a typical dairy farm will be different than what is stored in the lagoon of a farm with a digester. The typical dairy farm will store all of its cow waste in its lagoon. However, the lagoon on a farm with a digester will hold the liquid that comes from the anaerobic digester. Nearly all of the solids were separated out earlier and do not go into the lagoon. We'll catch up with the solids from the digester later. On a farm with a digester, the storage lagoon is a specially lined in-ground liquid storage pond near the farm. A liner is used to protect groundwater supplies beneath the lagoon from any kind of contamination from above. A liner of compressed clay will always be used. If conditions require it, a second lining of thick plastic may be applied over the top of the compressed clay. All of the liquids from the solid separator are conveyed to the lagoon for storage. Remember that most of the harmful bacteria have been removed from this liquid. Most of the odor has been removed as well. Finally, the nutrients that remained in the raw cow waste have been mineralized. Those nutrients have been digested and converted from an organic to an inorganic form. In this form, those nutrients are now much easier for plants to take up and use. Dairy farms without digesters almost always store their raw, untreated cow waste in a lagoon too. It's important to note that untreated cow waste has challenging characteristics that digested liquids do not. Untreated wastes retain their pathogenic bacteria and their strong odor. Sitting in a lagoon, untreated cow waste will slowly decompose, releasing methane, a powerful greenhouse gas, into the air. As a rule, these challenges have been solved through anaerobic digestion. Lagoon storage of digested waste is much easier and less problematic. The digested liquid stored in the lagoon should now be looked at as an especially renewable and sustainable green asset. How that asset is used will be considered next. Liquid fertilizer. Through its treatment in the digester, the liquid now in the lagoon has become an exceptional renewable asset, a very effective and green liquid fertilizer. Note the tankers parked next to the lagoon in the picture. When needed, the liquid fertilizer in the lagoon will be pumped into the tankers and driven to a field for application. A tanker truck might actually drive the fertilizer out into the field, or the fertilizer may be piped through very long flexible hoses to a rig in the field. Either way, an application rig will deliver the liquid fertilizer into the soil. 3 common methods of application are usually used. In one method, the rig will slice a narrow furrow a few inches deep into the soil. Just behind that, the liquid fertilizer will be injected into the ground just below soil level.
Traveling along about 7.5 miles an hour right there.
In another method, a rig will uniformly spray the liquid fertilizer onto the field just above soil level. The fertilizer is then incorporated into the soil with knives just behind the spray. In the third method, the liquid fertilizer is also sprayed just above soil level, but it is not incorporated into the soil. Usually, this is because it is being broadcast right onto a field of growing plants, something that cannot be done when raw cow waste is put onto a field. The methods of delivery just described, the most common ways to apply digested liquid fertilizer, place the fertilizer right where plant roots can most easily get it, and it is applied in a way that is least likely to allow runoff into a nearby waterway and cause any kind of environmental problem. How much liquid fertilizer will be used? That is determined according to the farmer's nutrient management plan. The farmer applies just the right amount of fertilizer for a desired crop to grow without using too much. Using too much fertilizer wastes money and resources. It also increases the chances of excess nutrient runoff into nearby waterways. This fertilizer is more effective and safer to apply because of its processing through the anaerobic digester. In the digester, odor-causing compounds in the cow waste were removed, harmful bacteria in the raw waste were drastically reduced. Finally, the organic nutrients in cow waste were broken down and put into an inorganic form. This makes the nitrogen, phosphorus, and potassium much easier for growing plants to take up and use. It is a common practice at many dairy farms to spread raw cow waste onto a field as fertilizer. Even if it is injected into the soil, it retains its odor and contains high concentrations of bacteria. Its nutrients need much more time to be broken down before they can be used effectively by plants. As these organic nutrients decompose in the field, some methane, a powerful greenhouse gas, will be released to the air. When cow waste is processed through an anaerobic digester, the methane that is produced is captured and used. If raw cow waste is broadcast onto the field, especially without being mixed into the soil, the potential for problems with runoff is heightened. Snowmelt or rains can drive bacteria and nutrients from the raw waste into a nearby waterway much more easily. The chance for eutrophication increases. Broadcast and surface spreading of raw cow waste should be done very carefully for this reason. What if a farmer chooses to use a synthetic, man-made fertilizer? Synthetic fertilizers will have no odor, nor will they contain bacteria. After application, their plant-accessible inorganic nutrients will be readily available to growing plants. But when a synthetic fertilizer is used, it is still not the best sustainable or green choice. Petroleum and natural gas compounds, non-renewable resources, are used in the production of synthetic fertilizers. In summary, digested liquid fertilizer is a renewable green asset having great flexibility for application, remarkably reduced odor, very low levels of bacteria and pathogens, and nutrients in a form that are readily available for plants to use. The application of digested liquid fertilizer plays a critical part in a dairy farm's nutrient management plan, keeping nutrients on the farm and out of nearby streams. It is often in high demand for this reason. Using it conscientiously closes the nutrient loop, safely returning to the field all of the nutrients from a cow's food that she did not use for herself or put into her milk. Now we'll go back to the solid separator to find out what happens to the solids that come from the digester. They are now called biosolids. After the solid separator, we followed the path taken by the digested liquid. What becomes of the large volume of solids coming out of the digester? The digested solids are called biosolids. The word biosolids fits, since the material recovered is a solid that has been through the process of anaerobic digestion. Biosolids possess two important characteristics, either of which can be taken advantage of. First, biosolids contain all of the nutrients found in the digested liquid fertilizer, but in a solid form. For these reasons, biosolids make an excellent soil amendment and fertilizer. A soil amendment is a solid material that, when applied to soil, improves its physical properties, like its water retention, for example. And the plant-accessible nutrients in the biosolids effectively fertilize the soil. Biosolid nutrients are also unlikely to run off when used as a soil amendment. Just like the digested liquids, biosolids have low odor and are low in bacteria levels. Dairy farmers with an anaerobic digester can supplement their incomes making money selling biosolids. Other farmers, plant nurseries, and businesses that sell soil amendments are ready customers for this highly desirable product. But biosolids possess a second characteristic that can save the dairy farmer a lot of money. Biosolids make an excellent cow bedding material. Biosolids fit the criteria for a cow bedding material nicely by promoting cow health, comfort, and milk production economically. Cows find it comfortable to lie in. It is a byproduct of anaerobic digestion and is readily available on site to the dairy farmer. In addition, consider what happens when the bedding needs to be changed in the cow barn. Compared with other bedding materials, biosolid bedding requires no special separation or handling. It can be mixed right in with the cow waste and be pumped into the digester again. To summarize, biosolids may be used as bedding material or as a soil amendment. In either case, we see something that was a waste product has once again become an asset. This asset is renewable, recyclable, valuable, and environmentally safe. We've covered what happens to the digested solids and liquids. What happens to the gas that is produced in the anaerobic digester? Time to follow what is now called biogas. To pick up the story starting with biogas, please make your way to Part 4, Biogas to Electricity.